next one.
When kids used to get those that got colors that had different smells.
Yeah, I remember those markers that had smells, and I'm not sure encouraging small children to sniff markers was the best thing to do, if I'm being honest with you. Like, I like those markers, but I don't know that we were sending the best message there. Anyway, let's talk about synthetic division. So last week we talked about how to divide polynomials, and this week we're also going to be dividing polynomials. For example, minus x squared minus 13x. Before you start griping about my handwriting, that is 2x to the third power. Stop bullying me. So the way that we solved this problem last week, I'm just going to refresh your memory, was that we put the thing you're dividing by on the outside. I don't remember. I think that's the divisor. I always get the divisor and the dividend mixed up. But you put one of them outside and one of them inside the shape. Did somebody write down? I know we Googled it last week. What was that thing called? Huh? It was a really weird name. Oh, you wrote it down? Answering the important questions. It's called the no, it was not called the bracket.
What did you say?
All right, you get back to me when you find it. So I'm going to work out this problem really, really quickly. Okay, we're not going to go through this step by step because this is what we did last week. But I'm just going to tell you, let's assume that we all did this problem together. Everybody had a rocking good time. We got the answer, and the answer is this. Okay. Let's assume we did the long division thing. And that's what we came up with. Okay? So synthetic division is a different way of dividing polynomials that will get you the exact same answer. Okay? So here's how you do synthetic division. First of all, in order to use synthetic division, we have to meet one very important condition. To use synthetic division. The divisor, which is the thing you are dividing by, I'm like 98% sure that's called the divisor. The divisor must be in the form x minus c. Now what we mean by that is the divisor must be plain old x minus a number. That can be a plus. If we subtract the negative, it's a plus, right? So it could be x plus c. But the point is, the divisor must be plain old x all by itself. In other words, the divisor can't be an x squared or a 2x. Can't be a coefficient, can't be an exponent. Does that make sense? It has to be just plain old x. Now the reason that's an important thing for us to point out here is that after you see synthetic division, you're going to want to do synthetic division every time you divide polynomials. It's that fast and that easy. You're going to want to use nothing but synthetic division. You can't use synthetic division 100% of the time. You can only use it when you're dividing by a plain old x. Okay, so here's how synthetic division works. We were dividing by x minus 3. We are going to start off by making whatever the name of that shape was, except we're going to go this way. That's the synthetic division dividing sign. The number that goes right here in that little box is the c. Now remember, it was x minus c, so let's come back and look at what we were dividing by. We were dividing by x minus 3, so what is c in this problem? 3. Okay. Now to the side, on the other side of this little symbol that I drew, we are going to write 2x cubed minus x squared minus 13x plus 1. We're going to write that out. But we're not going to write any of the variables. We are only going to write the coefficients. So 2x cubed, we're going to write 2. Next was negative x squared. That's negative 1. Remember, if there's no number, we use a 1. Then we got minus 13x, so we do minus 13. And then after that, a positive 1, so we do a 1. All right.
So that's what it looks like. And then we're going to draw a line right here. Okay, so here's how synthetic division works. Works the same way every single time. Step number one is you take this first number, the 2, and you just bring it straight down. I know it looks like I'm doing witchcraft right now, but once you see it a couple of times, it's going to come very naturally to you. Okay, then you do 3 times 2, and you put the answer right there. So 3 times 2 is 6. The 6 goes right there. Then you add this column, -1 plus 6 is +5. Okay, then we repeat the process. We do 3 multiplied by 5, just 15. And then we add this column, -13 plus 15 is 2. Okay, then we go again. 3 times 2 is 6. And we add this last column, which is 7. Okay, we've reached the end, so we're done with synthetic division. This is the order every single time. The last number here is the remainder. This number is the constant, the plain old number. The next number is the x. The next number after that is the x squared. So my answer is 2x squared plus 5x plus 2 with a remainder of 7. How do I write the 7? If you write R7, I get to slap you one time. It's 7 over the divisor, which was x minus 3. There's the answer.
Now I want you to compare the amount of paper and the amount of writing we used for a synthetic division problem with what you did last week. Compare how much space it took us to do long division versus how much space it takes us to do synthetic division and how fast it is. Synthetic division is much, much easier. It's much more difficult to make a mistake in synthetic division. It's much faster, less writing, less paper. More people will like you. Your body will become stronger and your mind sharper.
I have a question.
Yes.
So in the original on top is x cubed, so is it still x squared or x?
Yeah, because remember when we divide it in the long way, the first thing that you do is what is 2x cubed divided by x? X cubed divided by x is x squared. So that is exactly right. That's why it ended up the same. Cool. Let's do another one. We're going to practice this a few times, and I think once you get the hang of it, it's going to be really, really easy for you. So let's do 4x cubed minus 3x squared minus, let's do plus 6x plus 5, and we'll divide by x minus 1. Okay, so the first thing we do is the synthetic division symbol. That's this thing. And the number that goes here in this sort of like sideways L is the C. We're dividing by x minus C. So in this case, C is just 1. X minus C, so the C is 1. Okay, we'll put our line here. Right next to the 1 on the other side of the symbol, we're putting all the coefficients of our problem. So it's 4, then -3, then +6, then +5. First one goes straight down, bring down the 4.
Then you multiply. 1 times 4 is 4. Then add this column. Negative 3 plus 4 is 1. 1 times 1 is 1. Add that column. 6 plus 1 is 7. 1 times 7 is 7. And then add that column. 5 plus 7 is 12. This last one is the remainder. That's the constant. That's the x. That's the x squared. So my answer is 4x squared plus 1x. I'm just going to write that as plus x. Plus 7 plus the remainder, which is, there you go. And that is synthetic division. It's really easy. I like it a bunch. Of all the ways I could divide polynomials, that one might be my favorite. We're going to do a couple of more challenging synthetic division problems. And really, when I say more challenging, I just mean longer. The process is exactly the same every single time because you're always dividing by something similar. You're always dividing by x minus something, or in this case, x plus something. So more challenging just means longer. So we're going to do a couple of just plain synthetic division problems. I'm going to show you an application of synthetic division problems called the Remainder Theorem.
So in this whole process, that first one is always dropped down to x.
The first number is always just dropped straight down.
Yeah.
Right.
Your answer is always going to be a square left.
Yes, just like when we did long division, the answer was always a square less. Yep. Or an exponent less, I guess we should say. Okay, so here we go. This one's tricky. Should it be 2? It's x minus c. That's not a minus, though. It's a plus. So this is like x minus negative 2. Minus a negative is the same thing as plus. So c is negative 2. Very good. And the only thing that's more difficult about this one is the thing we're dividing by is bigger. Instead of starting with x cubed, we start x to the 4th, which means we're going to have one extra term in our answer. So here we go. What's the coefficient? 1. Okay. Then negative 2. Then good. 5. Let's draw our line here. The first one always just drops straight down. Yeah, but it's not 2 times 1. It's negative 2 times 1, which is negative 2. Good. How about positive 8? Negative times negative is positive. Good. Good job. Then we add them. Negative 11 plus 8. Negative 3. Good. Uh-huh.
Negative 3 times negative 3 is 6.
Positive 6. 11. 5 plus 6 is 11. Negative 2 times 11. Negative 20. Which would leave us with 12. Remainder, constant, x squared. What's that one going to be?
X to the 3rd.
That's x to the 3rd. Good. So my answer is 1x cubed minus 4x squared minus 3x plus 11 plus my remainder, which is 12 over x. There you go. They don't get way harder than that, to be honest.
Let me give you one to try on your own. I'll give you a couple of minutes, see if you can work this one out. X to the fourth plus 3x cubed minus 5x squared plus 6x plus 12 divided by x plus 3. I'll give you just a couple of minutes. See if you can sort that one out. We're making the magic happen? Still working?
Okay.
Three dogs.
Hmm?
You have 3 dogs.
No.
One of the answers equals 0.
Well, let's start off with the obvious stuff. What's C? -3. If you messed up on that, you were going to have a bad time. So what are the coefficients that go next to it?
1,
Mm-hmm.
3,
Mm-hmm. Good.
6, and 12.
Good. Okay. Bring down the 1.
-3 times 1 is -3. Makes it 0.
Mm-hmm.
0,
0.
and
Uh-huh. Good.
Negative 5.
15,
Mm-hmm.
15.
21,
21 is
Mhm.
your answer.
-63,
3.
and
Negative 51.
Negative what?
51.
51. Good.
50.
Thought you said 59.
No,
Alright.
51.
So cool. So the final answer should be, well, that's the remainder. So constant x.
So how do you write?
So 1x cubed. If it's 0x squared, I don't need to write that. I'm just going to skip the x squared.
Okay. So that's what I do.
Minus 5x plus 21. And then minus 51.
Over x.
It would be okay to do plus and then a negative 51 over x plus 3.
There's nothing wrong with that. Like, it looks weird, but there's nothing wrong with it.
What will the computer do?
Luckily for some of you, we don't judge things based on whether or not they look weird. Either answer is acceptable. They're both fine. Cool. So let's talk about an application of synthetic division, which is something called the remainder theorem. The remainder theorem is kind of cool. I'm a big fan of the remainder theorem. Okay, so in order to do the remainder theorem, you got to remember what function notation is. Let me give you an example of a function. In function notation, p of x equals 2x cubed minus 4x squared plus 5. Okay, there we go. There is a function in function notation. The p of x is the thing that puts it in function notation. Okay? Here's my question. What's p of 2?
That should be your x now.
Right. So I'm going to rewrite this function, except everywhere I have an x, I'm going to replace it with 2. So instead of p of x, it's p of 2. Instead of 2 times x cubed, it'll be 2 times 2 cubed minus 4 times 2 squared plus 5. This is reasonably simple arithmetic. 2 times 2 cubed is 8 minus 4 times 2 squared, which is 4. Okay, so exponents first. Then our dear Aunt Sally says do multiplication next, so we'll do 2 times 8, 4 times 4. And then Aunt Sally says do addition and subtraction from left to right. So 16 minus 16 is 0, plus 5 is 5. So our conclusion, p of 2 equals 5. Now, hopefully what you're thinking to yourself right now is, that's not the remainder theorem, you just plugged a number in, and you're right. We haven't done the remainder theorem yet, we've done that a million times before. But that answer is important to us. Keep that in the back of your mind. Let's come back to the problem, which was 2x cubed minus 4x squared plus 5. And now let's do some division, and let's divide by something where the c is 2. Now, dividing by something where the c is 2 means we're dividing by x minus 2. If the c is 2, we're dividing by x minus 2, right? That makes sense? Okay. Let's do synthetic division here. So inside my little synthetic division shack is going to be the 2. We'll do 2, negative 4.
Really?
I'm missing something. I'm missing the x. So 0 for the x. So you have x squared and a number but no x. Just like long division, got to have that placeholder there. Okay, put that in there. And then 5. Cool. I tried to trick you. I'm a tricky, tricky white boy. So now let's do the long, or not the long division, the synthetic division. Bring down the 2. 2 times 2 is 4. Negative 4 plus 4 is 0. 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. And 5 plus 0 is 5. 5 is the remainder, and I'm done. 5 was the answer when I plugged in 2. So what the remainder theorem says is, if you do synthetic division divided by the number that you wanted to plug in, the remainder of that synthetic division problem is the same as the answer if you were to plug that number in. That's what the remainder theorem says. The remainder of synthetic division is the same as the answer if you plug that number in. So, if we go back to our first problem, what we're saying is if I took 2x cubed minus x squared minus 13x plus 1 and I plugged in 3, I would get 7 for my answer. If I were to take my second problem,
4x cubed minus 3x squared plus 6x plus 5, and I were to plug in the number 1 in place of x, I would get 12 for my answer. What number did I plug in on this one? -2. If I substituted -2 for x, I would get 12 for the answer. Okay? Let me see if I can really bake your noodle. Did you just say sure? You say sure a lot. Sometimes I don't think you mean it when you say sure. That is a doozy. Keep on guessing. You're a goofy dude.
What do you notice about the function that I gave you? It's missing quite a few things, right?
Well, you're missing 3 squared of x to the third.
I'm missing x to the third.
Even x and number.
And x and the constant. I'm missing all of those things. Those have to be included when I write this out. I was going to use zeros for them. We'll start off with the easy part, though. What's the number that goes inside the little hook there? 4. And somebody call them out. What are all my coefficients going to be? 4, 35, 0 for x cubed, then 17 for x squared, then 0 for x, then 0 for the constant. Now this is an example of one of those times when synthetic division really shines, because plugging in 4 to this function, the math word for that is that it sucks. The first thing I would have to do is 4 to the 6th power. I can't even do that without a calculator. 4 to the 6th, that's a big number. Not only does it sucks as soon as you start doing it. Synthetic division is much faster. How do I do this with synthetic division? What's step 1? Drop the 4. 4 times 4 is 16. -25 plus 16 is? You're right, -9. Then 4 times -9 is? 36, good. 35 minus 36 is -1. -4. 0 minus 4, -4. 4 times -4 is? Good. 17 minus 16 is? 4 times 1 is 4. 0 plus 4 is? 4. And then 4 times 4 is 16. 0 plus 16 is 16. I don't even care about the whole problem because I just wanted to find P of 4. What's the answer?
16.
There you go. Now you would have gotten 16 if you'd plugged in 4 to this equation. You would have gotten 16. You just wouldn't have enjoyed it. 4 to the 6th power is terrible. If you thought that was the only bad part, then you got to do 4 to the 5th and 4 to the 4th. It's really ugly. Synthetic division's way faster and way easier. We would have to have a calculator to plug in 4 to this. We don't need a calculator if we do synthetic division. It takes us less than a minute. It's really quick. What? That's pretty racist of you to say. That's even worse.
Sure.
I can't really explain why that's... I mean, it's not offensive, but it's racist. I mean, because it was about race, so by definition, racist?
No.
Does racist just mean it's about race, or does it have to be negative to be racist?
I'm citing your abilities.
I would Google it, but I don't want that in my search history. Does it have to be negative to be racist?
Does it depend on perception?
I guess so. I better go ahead and report you, though, just to be on the safe side.
Sure.
All right, last one of these. Give you just a minute. See if you can sort it out yourself.
Okay.
Give you literally 1 minute. Don't blow it.
Sure.
I'm timing you. 60 seconds. Go. Try not to embarrass me. You think you got it? I will take it that means you're done. I mean, you're finished.
Yes.
All right. What'd you do?
3.
3. Good. Okay, here was the tricky part. What are the coefficients? 2. Good. There we go. 0 for the cubed. 90.
0.
59.
Oh, yeah. 50. And then 0.
And then 0 for the constant. Good. You guys are so smart. I might start telling people I know you. Drop the 2.
Goes.
That's what I say every time I go into the bathroom. Then what?
2 times 3 is 6.
Good.
Makes it negative 12.
There you go.
Oh, I'm sorry. No, I was reading about negative 36.
Negative 36.
Equals negative 36.
How about that? Oh, here's where it gets a little gross.
And then negative 108.
Very good. Negative 108.
And then minus 18.
Good.
And then negative 54.
Good.
And then 5.
Multiplication skills so strong.
15.
15. So the answer is, again, synthetic division, even though we had these big numbers, is a big, big time saver. Plugging 3 into this, even with a calculator, plugging 3 into this takes a while. And the numbers along the way are gross. Let's avoid that if we can. Does anybody have any questions about synthetic division or the remainder theorem?
So the 15 is answering what question?
The 15 is the answer to the question, what would happen if I substituted all the x's with 3? If I did 2 times 3 to the 5th minus 18 times 3 to the 4th plus 90 times 3 squared plus 59 times 3. If I substituted 3 for the x's, what would I get for the answer? And it's 15. And I don't even... this is what it would look like if I did p of 3. I don't even know if I can do this without a calculator. Let's try it.
Either this is going to be the right answer and you're going to be really impressed, or it's going to be the wrong answer and you're going to think, my God, my math teacher can't multiply. So 3 to the 5th is 243. And 2 times that is 486. Okay, so 3 to the 4th is 81, and 81 times 18 is nauseating. $1,458, perfect. Plus 3 squared is 9. 9 times 90 is 810. And 59 times 3 is 150 plus 27, which is 177. Okay, so let's put the positives together. This is so gross. So it's 1,473 minus 1,458. Which is 15.
Now listen, if you really want to substitute 3, I don't want to stand in the way of your dreams. That was super fun.
You did a great job.
But I'm going to make the argument that synthetic division is faster and easier. And although I think we're all on the same page here when I say that we love math and want to do as much of it as possible, I'm going to go with faster and easier every time. I mean, this is fun, don't get me wrong. But let's have fun quickly.
Let's get it over. Too much fun for one day.